All right, so the next thing we'll be checking out in this video is theorem 1, and this is a theorem on the left and right cancellation law. So we have to prove that a group, we have let G comma star be a group with an identity element. So the left cancellation law, we have to prove if the left cancellation law holds if and only if. So what we have here is if and only if and only if s is equals to y. This one, if and only if s equals to y. So what this is saying is that at the end of the day, we must prove that s is equals to y. Any theorem that you are dealing with in algebra generally, and you have the theorem to be s to be equals to y, what it simply means is that what it implies is that at the end of the proof, this is what you are proving at the end of the day. Now, since it is a left cancellation law, and we have this one is the left cancellation while this one is the right cancellation, so you can see it is word and opposite. So to prove this, we let a star s comma a star y comma a comma x to be in the group, to be a group. So since it is a group with an identity element, what you do is that um you take you look for a way such that an identity element occur in the theorem. So for an identity element to occur, what you do is you multiply um all of this with, you multiply the left cancellation and the right cancellation with an inverse. So it simply means that we have a inverse star a star s. So we multiply this by a inverse, so we equate it to the other part, a inverse a star y. So we multiply both the left and the right cancellation by a inverse. And don't forget that, note that a inverse star a is equals to an identity element for every value of a in G, right? Don't forget that. So if that should be the case, from this part, from from equation star, we'll be having E star S. This is going to be E star S, since A inverse star A is equals to E. So we'll be having E star S, which is the same thing as E star what? E star Y. And since this is an identity can be zero, identity can be any number that is being added to an identity is still the same number. So this is S is equals to Y. This is the end of our proof.